Alright, in this problem it tells us given m, the lowercase m is just the measure of arc, that's that little symbol above, it's not a line. WYZ is 240 degrees. So quick geometry lesson, you just go through those 3 points in order. W, Y, then Z, so W, Y, and then Z. So all of this in pink is 240 degrees. They want us to find the measure of the arc, so that's on the outside, YZ. So I recognize here that if I add the pink plus the blue, pink plus the green, a whole circle has how many degrees? So how much does that one have to be? It has to be 120. The next question says the measure of angle YXZ. So this angle here, in blue, back in geometry you learned that if the vertex, or this angle is on the center is equal to the arc. So this is going to equal 120 degrees. Now it actually wants to know the length of, the arc length of YZ. So I'm going to write down my proportion. Partner A, tell partner B what's the awesome proportion we're going to use today. Lily, what is the proportion we're going to use? Well, we're going to be using arc length, so it's going to be just 2 pi r, because we're talking about comparing it to the circumference, not the area. So our arc length is 2 over 2 pi r. Class, do we have the central angle in degrees? How much is it? 128. Now, before I write 360 again, this tells me a hint of one of the factors. Let's see if it works. 120 times 3. Does that make sense? And in the numerator, I'm going to write a times 1. 120 times 1 is 120 degrees, which is our angle, and 120 times 3 is 360. Do we have the arc? You're not going to put 120 degrees here. I want the length. This is telling you the angle measure. So YZ is the name of our arc. So I'm going to write YZ, and then you put an arc above it. And then 2 times pi times my radius. Do we have something for the radius? 6. I'll leave the units to the very end. So over here, I can cancel. What am I left with, class? 1/3. And the reason why I wrote the 1 up here, some students will actually think it's 3 is the answer. If they don't have a number up there, they'll think they'll cancel everything and they see the only thing that's left is a 3. No, it's 1/3. And that's 12 pi. And that should make sense. 120 degrees is 1/3 of the whole circle. Therefore, the arc length, green here, is going to be 1/3 of the whole circumference, right? That's what the proportions mean. So just to solve this algebraically, I'm going to multiply both sides by 12 pi. And remember that I did that because the opposite of division is multiplication. And you can make this a fraction by putting it over 1. And then I can do some canceling. What can I cancel, class? 3 goes into 12 how many times? And what's left over here? Our arc YZ. Now, I want to talk about this answer here. This answer over here is in terms of pi. Let's write that. So if I tell you to leave your answer in terms of pi, you should have pi in the answer. Do you see that? I may tell you to round to the nearest hundredth. Show me with your fingers. Nearest hundredth is how many decimal places? Hundredth means 2 decimal places. So here's your hint. Look. When you see the directions round, you put a round thing there. That's called a decimal. Okay? Why do I say that? Some students will get confused. I say leave in round your answer to the nearest hundredth, and you put 4 pi as your answer. Although that is correct, and what I'm asking for, you're going to get marked down, probably marked down to 3 out of 4. Does that make sense? Let's use our calculator. Make sure you're on degree mode. It says on my screen. I'm going to write 4 times pi. And I have it to the nearest hundredth, so I need the 2 decimal places, which means I need to look at the third one. This is 5 or higher, so my answer is going to be what? 12.57. And now I can go back and put inches if I need to. So on top here, I can write 4 pi inches, or I can write approximately 12.57 inches. And that's how you find arc length, and also a quick review of the different types of arc angles.